The Common Core authors have articulated an emphasis on focus, coherence, and rigor. Their use of the word coherence refers to the idea that concepts are not like a checklist of skills to be ticked off as they are achieved. Rather, concepts need to be developed coherently over time. Teachers need to understand these developmental sequences in order to better teach the content at their grade level, as well as to respond to variation in individual learners. In this presentation, we will be looking at counting from the coherence perspective. Counting is only listed as a domain in the kindergarten Common Core, but of course, counting begins earlier in preschool, and it serves as a critical foundation for subsequent learning in number and base 10, as well as operations and algebraic thinking. The types of counting that are listed here are not mere classifications, but they also describe a developmental pathway. Typically, the students are well established on this path by the time they arrive at school, but there is considerable variability in entering kindergartners, and so teachers need to be aware of these types and consider where children are along this pathway. Knowing where children are on their learning journey, and especially knowing what the next developmental pathway is on their horizon, allows us to be very targeted in the kind of interventions that we design to support their progress. This presentation includes some suggestions for the kinds of tasks that might support learners at different stages. Children begin by learning the rote counting sequence. Knowledge of the number word list, i.e. being able to know the counting words in order, precedes learning to count in any meaningful way. Quite young children can learn to count to 10, but they may have limited understanding of what that means. They may pretend to count by naming the counting words while imitating the act of counting. At this stage, there is no synchrony between the verbal counting words and the objects being counted. Still, this is an important stage of development. Practice with the rote counting sequence helps learners to develop the stable order principle, which is knowing the order of the number words, recognizing that that order is very important, recognizing that you just can't switch the order or skip any numbers out. This stage is also important for children to begin to recognize that counting is an act of quantifying. Most kindergarten children will be beyond this stage, but if you encounter a child who fits this description and who can count rote to 10 fluently, but who is not pointing with one-to-one correspondence, then you will want to facilitate this with particular tasks that foster one-to-one correspondence. To foster one-to-one correspondence, there's a need to slow down the count sequence so that it can be brought into synchrony with the objects being counted. By synchrony, I mean that one counting word needs to be stated with one object. Of course, that is easier said than done. Here are a couple of ideas inspired by things that I've used and also ideas from Mathematics Their Way. To slow down the rote count sequence and foster coordination, you can have children add actions to their rote counting. For example, you can tell children that you are going to count to 8. They should stand in a column and stomp a foot for each number word. When they get to 8, they can wave their hands at the teacher. This little activity puts counting words into synchrony with foot stomps. It also, through the waving at the teacher, emphasizes the importance of the last counting word in the sequence, which is going to become an important idea down the road. One feature to look out for if you do this exercise is, are the foot stops truly in synchrony with number words, or are they just in synchrony with syllables? When you think about the counting sequence, 1, 2, 3, 4, 5, 6, all of the words up to this point are a single syllable. Watch carefully what the students do at 7. One number word, 7, should get one stomp. It's 2 syllables. Don't let them do 2 stomps. Another idea is that you can actually use your voice or a recording of your voice to count, let's say, to 8. And that can become a center where the students have a sheet with dots, and as they hear one number word, they move one bear to one dot, and they continue to do that as you count up to 8. You, on the tape or in person, can repeat the count several times, so the first time they can build their set of bears, the next time they can double check their numbers of bears, and the third time they can double check a peer's set of bears, so that they get 3 times counting to that target number. Many children know finger representations of 4 quite early, so another idea involves counting out 4 items by for counting out 4 items is to have them show you 4 on their fingers first, and then move 1 Unifix cube to each finger. You can place it right on the fingers there, and that way they can build a set of 4 using a 4 that they know, which is their 4 fingers. Now, these tasks can improve one-to-one correspondence, but it still doesn't guarantee that they will be counting meaningfully, or that they will even recognize that the number 4 is the combined group of all of the objects that they just developed. When playing a game such as Hi-Ho Cherry-O, they can count out the number of cherries by placing 1 cherry on each dot of a dice card showing 4 dots, or they can place 1 cherry in a different chamber of an egg carton as they say the number word that goes with it. Playing any game that requires moving game pieces across a certain number of spaces can also be useful in fostering one-to-one correspondence. When children have learned to coordinate their verbal use of the number word list with their fingers as they point to objects, then they are at the point counting stage, where they say 1 number word and point to 1 item. But it's still quite likely at this point that they may double tag items, they may count some more than once, they may not count some others, they may skip them. And this can be the result of 2 things. Poor strategies for keeping track, that's something you can do something about. Also, it could be that they have yet to develop a sense of the cardinal principle. This is a very big mathematical idea that it is necessary in order for students to be able to be said to meaningfully count. Now, there are some instructional tasks that you can use with point counters, interventions, if you will, that can be used to foster student strategies for keeping track during counting. Here you see a mat partitioned into 2 regions. Students are encouraged to move the counters from one region to the next as they count the items. You will need to provide sufficient modeling by actually using it as you count a group of objects out loud, moving them across the line as you count. In the previous example, children are counting movable objects. They need quite a bit of experience counting real objects. However, we also want them to be able to count objects on a page, and these objects are not movable. Therefore, the strategy of moving items from one region to another is not available when they switch to paper. On this slide and the next, there are some images taken from an excellent resource called Visible Thinking in Mathematics, which you will find in the references section. This book is actually from the 1st grade resource, but it is the very first experience in the book and can be used with 1st graders coming in after a summer break, so it should also be suitable for late kindergarten. You see that the task begins with a teacher-posed question to students about how they keep track. I would suggest that you elicit some of the students' ideas before showing them this image. Then you can read the title, Crossing Out While Counting, and show them the first image. If you use turn and talk partners, this would be a good time to have them share in partners. How do they think the person counted the objects? The second diagram can be dealt with similarly, and the students can then try out these strategies with diagrams similar to these. They should also be encouraged to think about which of the strategies they like best and why. These images are taken from pages 5 and 7 of the same book. You see them exploring the idea of 2 kinds of visual paths. One which imagines the objects in rows and moves left to right like we do when we read text, and the other image involves students visualizing a circular path. Then they have a chance to try it out for themselves. What you've seen in the last 2 examples here are kindergarten children learning to use appropriate tools, such as visual images and concrete materials, strategically. This is mathematical practice standard number 5. To some extent, you could also say that they are looking for structure in the arrangement of the materials and considering ways to take advantage of that, which is standard 7. And they are also learning to be careful and precise in the counting task, which represents early work on attending to precision, math practice standard 6. Rational counting is a significant stage because it is the type of counting which students can be said to count with meaning. It requires everything they have learned to do in the previous stages, such as knowledge of the number word list, one-to-one correspondence, keeping track of counting, and also another big idea that children build along the way, This new aha is called cardinality. This is a recognition that the last word they say represents the quantity of the entire set. It sounds so simple to us, and there may be a temptation to think that we can just tell students this aha and get them there faster. But regrettably, this is not the case. The good news is that there are tasks that can foster this understanding, and they will be addressed later when we give cardinality our more focused attention. A related idea that is also necessary for rational counting is that numbers are nested inside each other. Perhaps you've seen nesting dolls such as those shown in this picture. Each larger doll contains all of the dolls smaller than it as well. Children must come to realize that our number system works the same way. 5 objects has the previous 4 objects plus 1 more object. Coming to this realization is an important part of developing the cardinal principle. As you will probably hear repeated many times in this module, children need significant counting experience in order to develop expertise. However much you think the word significant means, it's probably still not enough. Look for every opportunity during the school day that can incorporate counting, and let parents also know how important it is. Even after children begin rational counting, it is a while before the learners are comfortable enough with the quantities and how quantities are related to one another before they begin to count on. They must certainly have a very solid understanding of cardinality and nested numbers. When they say 8, 9, 10, 11, 12, and count on through the rote counting sequence, in order for that to have any meaning for them at all, they must be able to abstract that first value, recognizing that when they say 8, it means all 8, and not just the 8th item. Therefore, it would be unwise to try to push students in some kind of an assessment way on counting on until you're sure that these basic building blocks of cardinality and nested numbers are present, because counting on doesn't make sense to a child without them. If children do seem to have a solid understanding of cardinality and nested numbers for the target quantity you're working with, there are quite a few things you can do to facilitate counting on. One idea is to give students math story problems in which the first number is large and somewhat laborious to model, and the second number is small and easy to count on. In this case, it is still possible to solve it by representing each quantity with concrete objects, but for learners who are ready to count on, it looks so much more attractive and frankly less work to do just that. Another strategy I've used to help counting on is to give students 2 die, one that has numerals on it and one that has dots. I usually create my own dot die so that it's just 1 dot, 2 dots, or 3 dots on a particular side. And then when they roll, they have a numeral plus a certain number of dots, plus 1 dot, plus 2, or plus 3. And then they have to try to join them. Because one of the die is only numerals, they have to actually abstract that value. That's a strategy you can use if you think they're ready for it. Eventually, children learn to count groups of objects rather than just individual items. Skip counting is not overly emphasized in the kindergarten Common Core. There is a reference to being able to skip count by tens to 100, however, and we will be discussing that in the final week of this PD module.